A very good day to Dr. Suraya and all my fellow group mates. My name is Shiun with matrix number 210922, and today me and my group, which is group 4, will be presenting our analysis on symmetrical bending, which is on a balcony.
My name is Lim Hui Teng with matrix number 211305.
And my name is Teoh Jia Xin with reference number 211108.
Okay, for our example, we'll be using a balcony attached to a terrace house, which is approximately 3 meters in length. So for the introduction, unsymmetrical bending takes place when an object experiences an asymmetric load or unbalanced stiffness. This results in deformation and bending that differs for each side of the body. So in our balcony, unsymmetrical bending happens when there is a load distributed unevenly on the platform. To illustrate this, if furniture or people is situated on one side only of the balcony, then an imbalance is created and the load distribution will also be affected. This difference in loading causes the balcony to experience deflection on the heavily loaded side, which creates a downward sag on the balcony. And additionally, the balcony may experience some tilting, fatigue, or failure over the long period of time. So, in our report, we consider the balcony that extends 3 meters from the terrace house and is supported by horizontal beams with width of 75 millimeters and a height of 150 millimeters. So, the first step is to find the moment of in the y and z axis. We will multiply the moment with the angle, which gives us negative 8 kilonewton meters for my and 6 kilonewton meters for mz. Next, we'll find the moment of inertia in the y and z axis using the formula 1 over 12 base times height cube. So for the IY, we'll get 5.26 powered by negative 6, and for IZ, we'll get 2.11 powered by negative 5. So after analyzing the whole beam, we found that the maximum bending stress is situated on the upper right corner, which is a total of 249.03 megapascals. So hence, this maximum bending stress is immensely high. So I think as engineers, we should suggest some ways to improve the stability of the beam and hence improve the safety of the balcony itself. Do you guys have any suggestions?
For me, I think we can add 3 horizontal beams under the base of the balcony because it will make the base of the balcony supported by 3 horizontal beams become more stronger and more resistant against the bending force. Therefore, by doing this, it will enhance its strength and resistance to bending based on the concept of moment of inertia. Because, as we know, a larger moment of inertia will lead to a greater resistance to bending. So, when the cross sectional area of the balcony increases, it will effectively increase the moment of inertia, which allows the balcony to better withstand greater bending force and reduce the risk of unsymmetrical bending. So, how about you guys think?
Okay, Hui Ting, I agree that adding 3 horizontal beams may potentially increase the strength and stability of the balcony, but don't you think that adding 3 beams without any downward support will likely to increase the overall look of the balcony? So it turns out that the balcony is heavier than normal, and the 3 horizontal beams will not do any help in helping to stabilize the balcony. So I think we should have another suggestion.
If that is the case, I suggest adding 2 additional vertical beams underneath the balcony and connect with the 3 horizontal beams that Hui Ting suggested. The 3 beams suggested by Hui Ting can act as cross beams to further increase the strength of the balcony. And I would like to suggest another modification that could be made to the cantilever balcony, which is by adding 2 steel cables or rods at the end of the balcony and firmly attached to the wall. This type of balconies are called hung balconies, and it is easy to install and cheaper in cost for modification. And the absence of supporting columns or beams underneath the balcony frees up space and reduce the overall weight of the structure. This can result in a more efficient use of materials and potential cost savings.
But I disagree what Jasin suggests, which is adding the 2 steel cables, uh, because I think it is only useful for this small size balcony, and it is also for safety considerations only. But our balcony is big size, so it doesn't suitable for us to use it. And I think we can modify our balcony by adding two additional vertical beam connected with three cross beam to support the balcony. So that's all from me. Thank you.
Okay, I agree with Hui Teng also. I think that hung balconies are typically used on lighter and smaller balconies just for an additional support. So I think we should add three horizontal beams, which are also cross beams, and two vertical beams that support the balcony from the bottom. Because our balcony is not like those apartment heights, it's very tall. It will be cheaper and more effective to build two vertical beams underneath it to support it and three horizontal beams to support the overall layer of the balcony. So I think that is our final modification. Does anyone have any more suggestions to be made?
Yeah.
No,
Okay, so thank you to Dr. Suraya and my fellow group mates. I think we'll end our presentation here. Thank you.
thank you.
Thank you.